Okay, welcome back students. We're on question 12. It is a compound sort of triangle, a triangle with two triangles inside of it, whatever way you want to look at it. So we see the picture. We have a dimension of 3 meters and 53 degrees. So the left hand side smaller triangle is solvable. It's a right angle triangle, as we would expect it to be, mainly on the junior cert course. And then the right hand side triangle, to begin with, is not solvable, but through angle hopping and through problem solving we should get there. Let's go and find out what they're asking us. So in the diagram below, we can see that. We don't have to read it very carefully. We don't have to do battle with this. It's clearly on the diagram, and this is on the diagram, and this is on the diagram. So there's nothing up here that wasn't already in the diagram, and that's why when they're trying to split your attention, this is from a cognitive load theory called splitting your attention. Always go with the visual first. Don't go reading stuff which is available alternatively in a visual form. And if you can confirm that the written work is visual already, then you can ignore it. Very important. It's not always the case, but it's nearly always the case that this stuff is really superfluous. Work out the length of DC. So we need to find DC. It's here. Now I know from looking at this that we cannot do this directly. Okay? So we must do it indirectly. Just because we cannot readily go and calculate DC does not mean we give up. Okay? We agree that if we could find some other value like this one, then we can proceed using the formulas from page 60. Okay, in particular we have Pythagoras and then the definitions of sine, cos and tan. Some people call them SOHCAHTOA, something I will openly tell you that I despise, really, because I don't think it's helpful at all. Anyway, so let's get this AD value. So now we're looking at needing AD, knowing 3M, and where they meet is at the right angle. So from our knowledge of SOHCAHTOA, I just said it. From our knowledge of sine, cos, and tan, we know that it's tan. We use tan when we have the two sides of interest meeting at the right angle. So I'm going to write down that the tan of the reference angle, which is 53 degrees in this case, is equal to, we do not need to introduce a new variable, we know what this means, the length of AD divided by 3. Okay, so to solve for AD, we are going to do the inverse operation of divided by 3. In other words, we're going to multiply up the 3. Okay, we're also going to reflect, bringing AD to the left, and we will have that AD is equal to 3 times the tan of 53 degrees. Only now do you bring your attention to your calculator. Okay, so let's use the newer calculator. We'll do 3 times the tan of 53. Now there's a little R here, which is very, very troubling. That means I'm in radian mode. I want it to be a D in decimal mode. So if I proceed here, I'm not going to get the correct answer. Okay, this is in no way the correct answer. You can check it out by coming over here and doing 3 tan of 53 in degrees, and we get the answer we want, which is 3.98. Okay, but we do need to address the fact that this calculator isn't in the mode we want it to be in. So I'm going to try tools. No. Going to try catalog. We're looking for probably here. We want to be in degrees. No, that's not what I want. Tools. angle unit, that's what I want. So we want this to be degrees, and now I was getting it in radians. I'm also curious as to what's the default, so I'll do that in another video. I don't want this to become all about the calculator. And it's not letting me out. I'm going to do home again, won't work. This, and now you see the degree that I needed it to be. And sure enough, now if I do 3 tan of 53 degrees, but I'm also going to double check what happens if I reset the calculator. Now resetting over here is under behind the 9. Do we see any place here to reset the calculator? Okay, we'll come back to that later, maybe under settings. Yeah, settings, reset. I want to do a full reset, initializing all. And it'll ask me, reset, okay, initialize all, yes. Okay, and now when I do go tan, yeah, it is D. And it'll be the same here if you reset. Resetting here is a bit easier. Okay, let's get back to the calculation. Oh, and I didn't even write it down, did I? I wrote it up here, 3.98. It didn't give me anything about the precision level. Let's look at my answer here, 3.98, and just let's store that to A, so I can get it back whenever I want, just in case. Okay, so now of course 3.98 isn't my answer, it's AD. So now I'm going to go and say I want to calculate DC, and so now the definition of tan of 30 degrees is 3.98 divided by DC, sorry, length, DC. Okay, so I'm going to bring up the DC and bring down the tan. So the DC comes up and the tan goes down. I'm actually going to use the A I used in my calculator there over the tan of 30 degrees. Okay, now because of, if those of you who've been working very hard on your special triangles will know the ratio of the sides in a 30, 60, 90 are 1 is to 2 is to root 3. And so when you do the tan of 30, you get 1 over root 3. And so if you're dividing by tan of 30, you're actually multiplying by root 3. It's just, this is not voodoo, this is not a trick, this is just the exact same calculations. Is 3.98 times root 3. Okay, and I'll show you that that's the case. The DC is 3.98 root 3. Let's look at it. I'm not going to use 3.98, as I said. I'm going to use the exact answer that I stored in my calculator by going alpha A. There it is back. And I'll multiply that by root 3, which is the same as dividing by tan. We get 6.89. Does that look reasonable? It does. 6.895 dot dot dot. And just to convince you that I'll get the same answer, we're going to look at our 3.98 over tan 30, or our A over tan 30, and sure enough it'll come out the same. Okay, and again, nothing about, and this is probably the kind of thing you'll see on in an edco paper, I suppose, in that it didn't ever get. It might have got the same sort of peer review as other papers. So they never said the precision level, which is a pity because this is an irrational number. So there's no way of ever writing it exactly, except to leave it. Yeah, I'm not going to do that either. So we'll give the answer at 6.896. We're at the end of the paper now. Let's just take a quick look. Do we have units, by the way, meters? So that's important, or we lose 1 mark after all my talk. And we'll just take a quick look at the paper, at the actual solution that was offered to us at the back of the papers. 6.9, but that's just an arbitrary rounding, and our answer is perfectly correct. Students, as always, I will see you in the next one.